Hello everyone, welcome back to the channel. Today is the big day. Today is the day we're going to run integration tests as well as end-to-end tests of our application. The first part consists of running the integration test for our main view model, and the second part we're going to do the end-to-end test. Without further ado, let's jump right in and switch back to Android test. I'm gonna create here a new package. I'm gonna call it main, create a new class, let's call it main view model test. As usual, we're going to initialize the view model and we have to provide the needed dependencies. Under the function setup, we're going to provide and initialize the main view model. In this test, we need an instance again of the auth view model, and we are ready to run the first test. We need to make sure that the function load data should load the data and clear the cached user when failed to authenticate. Now let's act on load data. We have on success and on error. We need to make sure that this on error is not called. Therefore, we're going to add here a flag. Let's call it, for example, on error is called. It should be false initially. In error, we're going to change it to true. In other words, this block of code has been triggered or has been used. Next, we're going to observe the changes of the state under the main view model using Turbine. We have first of all, the loading state. We need to make sure that this plus screen is visible. And another state, which is again the loading state. Let's call it loading state. This time we need to make sure that this plus screen is not visible and the error is called. And we have to cancel and ignore remaining events. So basically what we are doing here, at first we don't have an authenticated user, therefore this block of code is going to be executed. I have noticed that we haven't used on downloading. Basically we're going to add it underneath the state and update. That's all for this test. Let's run the test. And hopefully we don't have any error from the previous implementation. We have an error. Let's investigate. Let's change this version to 21. Let's try again. And the test passed. Let's check the other test case, which is load data should load data including the cached user. First of all, we need to save some data to deal with. In other words, we need to save the user or to make some authentication. By doing this, we're going to save the dark theme or the default value of the dark theme. And we have to authenticate the user by calling auth repository and login. And we have to act. And we have to make sure that on error is called false. Therefore, I'm going to add here the same flag. And here, if it's called, we have to set it to true. On the other hand, on success, we need to assert. Let's call here this parameter user. User is not null. After triggering the event, we need to assert false. Error is called. All right, let's run the test. And the test passed. If you want to perhaps get rid of this warning, you can just do test by Turbine to consume the events, pass this flag here and copy the whole thing and paste it here. And let's try to check or to test. And the test passed. Let's make sure that the two tests does not interfere with each other. Now we are done with the integration test. All right, we are ready to tackle the end-to-end test. Under Pocket Goods, we're going to create here a new package for dependency injection. What you're gonna do here is to provide the same thing that we have done under wishlist feature, authentication feature, product feature, settings feature. We need to provide the mock data or the mock dependencies. In other words, under the end-to-end test, we're not going to test with the normal dependencies. For example, we're not going to use the physical database. We're going to use the in-memory database. Likewise, for the API service, we need a mock client and the mock API service. We have to provide the mock crypto service as well as the test dispatcher that's going to be used under the end-to-end test. Basically, this is the main focus of this DI package. Let's create here a new object. I'm going to call it app test module. It's going to be a normal health module. Next, we need to show health how to provide the dispatchers for the end-to-end test. Therefore, I'm going to create here another class. I'm going to call it end-to-end test dispatchers, it is the dedicated implementation for the end-to-end test environment. I'm just going to put it here under the DI. It's going to be called end-to-end test dispatchers. This class should implement the dispatcher provider that we have done under the core module. I'm going to add here the test dispatcher, a private value equal the standard test dispatcher. I'm going to assign main dispatcher. In this case, it is the test dispatcher. For the input-output, dispatchers and input-output. For the default dispatcher, it will be the test dispatcher. And for the unconfined dispatcher, unconfined test dispatcher. Experimental coroutines API. Let's show health how to provide this one. It will return test dispatcher provider, end-to-end test dispatchers. We need to provide the in-memory database. We need to provide the API service mock engine. We need to provide the API service or the mock API service. We need to provide the crypto service. Next, we're going to provide the repository, product repository, and the use cases for the product feature repository, and for the other repositories, wishlist, authentication, and settings. Yeah, a lot of dependencies to deal with, but we have no other option. That's pretty much it for the app test module. Let's make sure we have the test runner ready to go. And we have to add health to, we have added here, luckily, a to-do, add health test application. The class name, it's gonna be health test application, class.java, and name. We are going to proceed with a reusable pattern, which is very good. It's the robot pattern. Personally, this is my preferred way to proceed. I'm gonna create here a new package. I'm gonna call it robot. We're not going to implement anything here for now. And let's create another package that's gonna be where the end-to-end tests will reside. And another package for helpers, and that's all. What is basically an end-to-end test is a normal JUnit or Android JUnit test. Basically, it's going to launch the application and give the developer the access to the testing API and make some assertion. In order not to repeat ourselves over and over again, whenever we're going to do, for example, home screen tests or product detail tests, and so on, we're going to make an abstract class. This is, again, my personal implementation. I would like to add here an abstract class. I'm going to call it end-to-end test. It's going to set all the rules and the needed steps before conducting and running your end-to-end tests or individual tests, for example, home screen or product detail screen. Let's create here a new class. I'm going to call it end-to-end test. In this class, we're going to inject all the needed dependencies. Whenever you declare a module, Health will try to install and provide those dependencies. What I mean with that, we have 4 features. Health is going to inject all the dependencies, as well as the DI that we have provided here. In other words, Health will inject mock settings or mock dependencies, as well as the real dependencies. We don't want this. So we're going to tell Health in this end-to-end test, please do not install the dependencies from the core module, the wishlist feature, product feature, authentication feature, and settings feature. By telling Health to uninstall the dependencies, we are going to use only the needed dependencies from the app test module. This is basically the idea. First of all, we're going to annotate this with Health Android test. Then we're going to instruct Health to uninstall those modules, or not to take into consideration. The modules are core data, wishlist, product, authentication, application settings, feature. By doing so, after running the end-to-end test, Health will uninstall first those dependencies and provide the dependencies from app test module. This way, we're not going to use normal dependencies under our end-to-end test. We're going to use only the mock API service, the mock crypto service, as well as in-memory database and the mock engine. All right, let's annotate this class with large test. As shown here in the documentation, once annotating this class with large test, it's going to take some time to finish. And we're going to use Android JUnit. Before doing anything, you need to make sure that you are using the Android test runner. Under build gradle.kts, make sure we are using the test runner under this package. Basically, we are using this particular test runner, not a normal one. All right. Now we're going to set up the compose test environment and launch the activity to allow compose to give us the access to the compose UI test API by adding here the test rule. We have to do get, and we have to specify the order of the execution. We need to create or to launch activity at the second step. The first step, it's going to be for dependency injection. Therefore, we're going to use here or to assign the order to 1. And let's create the name of the rule, compose rule, Android compose rule of type main activity. In the UI test, the big challenge is the synchronization. If test does not wait for a task or a work to finish, it's going to result to a flaky test. Therefore, we need to use a technique called idling resource. Basically, it's a mechanism to tell testing framework, for example, like Espresso or Compose Test, when the app is busy or idle. Let's come back to the main app. Under util, let's add here the idle resource class. It's going to override idling resource. This class is going to implement the idling resource interface. Let's provide here the class name used by Espresso or the identification for this particular class. This Java class and name is idle now. It has to return the current idle state, whether true or false. Therefore, we have to create a thread safe flag, basically to keep track of whether the app is idle, otherwise true, or busy, in other words, false. I'm going to use here the atomic boolean. Make sure to import Java util concurrent atomic. We're gonna do is idle and get. Now we have to register idle transition callback. First of all, we're going to start the callback so we can notify the framework for testing when idle state changes. Let's create here a value that's gonna handle this. Basically, it's gonna hold the callback that Espresso uses to get notified when the app is idle. We're going to use here volatile. Basically, it ensures the visibility of the updates across threads. Volatile, private var, resource callback, idle resource, that's resource callback, and we have to set it to null initially. This resource callback equal callback from the parameter. And that's it for the implementation. I would like to add here a function to allow us to set idle state. It's going to take in parameter the idle state or whether the application is idle now. If we have a new state, we're going to update the value is idle. Now, if the new state is the same as the current state, we're not going to do anything. We will do here an early return. Next, we have to set new value is idle now. Basically, we are updating the idle state. In case is idle is true or is idle now is true, we're going to notify the test framework via the callback. Basically, the callback name is resource callback. And because it's nullable, we're going to apply the null safety operator and we have to call on transition to idle. That's pretty much it for the idle resource, for Pocket Goods idle resource. I would like to add here, just for testing purposes, if you want to log something under the logcat, just a companion object for the log tag. This is optional, you don't have to do this. Just gonna paste the name of the class here. Now we need to use the Pocket Goods idle resource under our main activity. Go back to the main activity and let's create here a new instance for this particular class, equal initially null. Now we need to assign this value whenever we are under test environment. Underneath, I'm going to add a function. I'm going to call it get idling resource, and I'm going to mark it with visible for testing. If idling resource is null, what we're going to do here, we're going to initialize basically the instance. Otherwise, we will return the idling resource. I'm going to create here a private function that's going to be triggered as soon as the loading starts. I'm going to call it on start loading. Under the events on loading data, we're going to set the application basically is idling to false. When it's done, it's going to be idle. It's going to be also visible for testing. Idle resource, because it's nullable, it's its idle state to false. If you will, you can add here a log. You can do, for example, not idle. The same function. In this case, it's going to be called on done loading. We're going to set idle to true, and instead of not idle is now idle. Let's come back to the onLoading. We're going to call the function on start loading and on done loading, on done loading. Now what's going to happen? When we are going to launch the application at first time, we're going to trigger to the framework of testing, for example, in our case, Espresso or Compose test, telling this framework the application it's now busy. It's going to wait for the application to turn from busy to idle in order to run the test. This is basically the idea. By using this mechanism, we're going to solve the problem of synchronization between basically the test and what's gonna occur under the main thread. Now let's come back to the end-to-end test. After launching the application or the activity, we need to set to get first of all the instance of the Pocket Goods idling resource, and we have to register basically this idling resource class. Therefore, we need here an instance of idling resource, and we need to launch the activity. Basically, we need here an instance of scenario of type activity scenario. First of all, I'm going to run the function before setup, some configurations before setup, and I want this block of code to be reusable. Therefore, I'm gonna add here an abstract function. Let's call it on setup. That's gonna be triggered by the consumer. And we have to annotate or to change this class and add here the keyword abstract. Now for the cleanup, which is very important, we need to get the basically the idling resource and unregister this class. Idling registry, get instance, unregister, idling resource. And we have to reset the dispatchers. This is a good practice. Now let's write the function that's going to allow the user to launch the activity or the developer to launch the activity. Basically, we have done pretty much the same thing under Cypress. Basically, this is the idea. We're going to write a reusable function that's going to launch for us the activity. Let's call it launch activity. And we have to assign the scenario from launching the application. Under helper, I'm going to create here a new function. I'm going to call it launch application. This is just a manner to organize our code. It's going to take in parameter a callback function that's going to be triggered before launching the application. Intent factory. Basically, this is the intent that's going to be launched. It takes in parameter a context. It returns an intent. Let's make it optional by providing the default one, which is the intent from the application provider. Get application context. And we have to pass the activity as a parameter. It has to be, let's make this function reusable. I'm going to add here a generic parameter or a generic type, an activity. And since we are dealing with generics, it's a good practice to add here reified and make this particular function an inline function. As a second argument, type A class.java. All right. And let's put here the extra to the intent. Basically, if you do remember under the main activity, we need to check or we need to add a flag here. Where is it? Whether we are under test or just a normal environment. That's what we're gonna do here. Let's copy first of all this key. You can add this key under constants. We're gonna put extra data here. And because this function is gonna be used solely for end-to-end tests, we're going to set its test mode to true. We'll return an activity scenario of type A. At the implementation, we're going to call callback function first. Then we have to return the activity scenario and launch the activity from the intent factory. And we have to pass here the context. Let's create here a value context equal application provider, get application context of type context. And let's pass the context in the argument. This function is going to allow the user or the developer to launch the application by passing only the type of the intent. In our case, it is the main activity. Let's come back to the end-to-end test. And we're going to do scenario equal launch application. And we have to provide here the type of the activity. It's the main activity that we want to launch. Then we have to configure the idling resource by doing scenario and on activity. What we're going to do here, we're going to register first of all the idling resource class, and we are under the scope of the main activity. If you do remember, under the main activity, we have implemented a function that's going to initialize the idling resource. Let's use this one under end-to-end test. It is it which stands for activity. You can rename this parameter to main activity. More readable this way, main activity, and get idling resource. It shouldn't be null. Then we have to register this idling resource by doing idling registry and get instance and register the idling resource that we have just created. Let's set the timeout for this idling resource. Another way, we're going to consider application idle after the timeout by doing policy or idling policies, set idling resource timeout. Let's do, for example, 30 seconds. That's pretty much it for the end-to-end test, and we are ready to use it under different scenarios. This is basically not only for this particular project per se, but in any project, if you will. The only thing that's going to vary, perhaps, is just the dependencies that you have to install. Let's take, for instance, some scenario that we want to write for it, some end-to-end test. I'm going to add here a class. I'm going to call it main end-to-end test. As usual, we need to annotate this class with health Android, install the dependencies, and mark it with large test. This part is very important. Let's inherit from the end-to-end test because this main end-to-end test is basically an end-to-end test after all. And let's implement abstract function setup. As I said before, the first rule that we have to apply under the test, we need to inject the dependencies by defining here a rule get. For the order, it should be the first, which is 0. Let's call it health rule. And we have under health a dedicated rule for this called health Android rule. And we're going to pass this class as an instance. On setup, we have to inject the dependencies. We're going to do health and inject. We're going to inject all the dependencies. Then we're going to do what we have done here, which is create the Android compose rule in order to access the compose UI testing API. Now we are ready to run the first test, which is basically the same thing that we have done under the Vuetify application. First of all, we're going to launch the activity. Then we're going to assert that we have the list of the product. I'm going to write only the skeleton of this test. Let's mark it with test. Let's name it, for example, test main app screen should have list of products. First of all, we're going to launch the activity. By launching the activity, we're going to do the whole thing that we have done here. Launch the main activity and set register the idling resource. Set the timeout to 30 seconds. And when the test is done, we're going to unregister the idling resource. We're going to reset the main dispatchers. All right. And this is actually the main purpose of doing this. You can run the test just like a normal class. It's going to be very chaotic and it's going to be hard to maintain. Let's come back to this. And we have to make here the assertion. I think that we are going to stop right here. For the next section, we're going to implement the robot pattern. I hope you have learned something new. See you in the next one and happy coding.